So in this video, we're going to take a look at absolute value, quadratic, and cubic functions. So with these functions, we're going to talk a lot more about these in later sections where we'll talk more about the properties and how to use them in calculations. But in this video, we're purely focused on graphing them and knowing what type of function we have, some key points to get started graphing so that eventually we can start graphing transformations of these. So our first function here is the absolute value function. So that's what this one is. And an absolute value, so an absolute value measures the distance between 0 and a number. So if we wanted to create a table of values for this function, let's grab some x values and f of x values. And let's go ahead with -2, -1, 0, 1, 2. So what we'd be doing over here is taking the absolute value of each number, but what we're looking at is the distance to 0. So if it's the absolute value of -2, well, on a number line, that's a distance of 2 units away. And the absolute value of -1 would be 1 unit away. So the key is that a distance is always positive. And in short with these, it's really, if it's negative, it turns the number positive. If it's positive, it stays positive. Like 1 has a distance of 1 away from 0, 2 has a distance of 2 away from 0. And then for 0 itself, the absolute value of 0, well, what is the distance between 0 and 0? It would be nothing. So that would also be 0. So the key points that we're looking at here, we're going to have 0, 0 as this turning point, and then 1, 1, 2, 2, 3, 3, 4, 4, just like we were graphing y equals x over here. And then to the left-hand side, it's where we had -1, we'd have +1, -2, +2, -3, +3. So we end up with this V shape here. And with that, I kind of think of these 4 key points. I even really just kind of focus on this 0, 0, and then at 1 away, we'd be 1 up vertically on either side. So when I start graphing the transformations, if it's an absolute value, this would be my starting point. So our function is, we'll see an absolute value in there. The domain goes from -infinity to +infinity, so we can plug in all real numbers here. But the range, notice we're not graphing anything down here. So we start at 0 and including 0, and then off to +infinity for the range. So when I get to transformations, if I see that absolute value, I'm thinking about these 3 coordinates as kind of my base structure of the function. Next up, we have the quadratic function. This is one you should have seen before, but I'll talk about it as if it was brand new, just to kind of help out here. So the quadratic function, the key that we're looking for is this exponent of 2 on x in our function. Our domain is going to be all real numbers, and our range is going to go from 0 to infinity. So as just a quick table of values here to kind of help us get some coordinates. Let's go -2, -1, 0, 1, 2. And what we're doing is we're squaring each of these values. And we want to think of it as having parentheses. So -2 quantity squared is a +4. -1 quantity squared is a +1. 0 squared is 0. 1 squared, 2 squared. So we have 0, 0. And then at 1 away, we're going to be 1 up. And 2 away will be 4 up. And with this function, I do kind of think of these 5 coordinates all together. With those, that can give me a good base structure. So when I start using transformations, we have a starting point there. Okay, and next up, we're going to have the cubic function. And with a cubic function, what we're looking at is x cubed. And this domain and range is going to be all real numbers here. What I think of as a cubic function in its initial form is increasing. So this is kind of our base structure here. We're going up and up and up with a little turn at 0, 0. So let's go ahead and make a little table of values to help us out get started. I'm again going to go -2, -1, 0, 1, 2. So -2 cubed is going to be a -8, -1, 0, 1, +8. So those are the key points that I want to focus on here. So -2, -8, -1, -1, 0, 0, 1, 1, 2, 8. Okay, again, there's so much more to these functions and ways of graphing them, but with this, I just want us to think about these key starting points so we can graph some transformations of them. Let's go ahead and try that out. So, with this first function, what I'm going to notice is this exponent of 2 where our value of x is showing up. So what that's telling me is the base form of this function, or we could call it the parent function. Let's go ahead and get that terminology in here. So our parent function is going to be our quadratic function, which is the x squared. So what I could think of is, before looking at any of the numbers, because I have this base with x in it and that exponent of 2, my parent function is going to go 0, 1 1s, and 2 4s. 2 4 2 4. That right there, and we could graph even more, but really we just need to follow a few coordinates. But that right there is going to be the start of our function. Now I'm going to take a look at what my transformations tell me to do. So multiplying by 2, that is going to tell me to do a vertical stretch by 2. And then for shifting, that x minus 3 tells me to go right 3. And then the minus 5 on the outside is telling me to go down 5. So I'm going to do this in 2 steps. Let's go ahead and take our parent function and take care of this vertical stretch by 2. So I'll still have 0, 0, but instead of 1, 1, I'll now have 1, 2, 1, 2. And then instead of 2, 4, I'll now have 2, 8. So there's our vertical stretch of some key coordinates there. So there's my stretch parabola. And then from there, let's go right 3, down 5. So I'm going to start with this coordinate here. So 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. 3, 5. And then we could just kind of use symmetry to help out with the rest of it. But what I am going to do is just check that the kind of dimensions carried over. So 1 away is 2 up, and then 2 away should be 8 up. Okay, we're good there. So my final function, I'm here, and there's my shifted parabola. So with this, what's kind of new from the last section is that we're recognizing our type of function, so it's our parent function, and from there thinking about those key starting coordinates that come through as a property of our quadratic function. And then we can start our transformation. Okay, let's go through a few more. So with this one, I'm seeing the absolute value symbol. So for our parent function, we're going to have our absolute value of x. So let's go ahead and just get that graphed. So we'll have a 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, so on and so forth. So here's our parent function. From there, let's go ahead and take a look at our transformations that we need to carry out. Okay, so the 1/2 is going to be a vertical compression by half. And then for the shifting, so 1 and 2, so x plus 1 would be left 1. And then the plus 2 would mean up 2. So let's go ahead and take the care of this vertical compression by half. So all of our heights are going to be cut in half. 2. So, and what even happens with this, because they were straight lines, is that it changes the slope of our line. So this would now have a slope of 1/2 and -1/2. So we can kind of follow that along. Okay, there's our vertical compression by half, so our graph kind of flattens. And then what we'll go ahead and do is go left 1 up 2. So left 1 up 2. Let's go left 1 up 2. Left 1 up 2. And left 1 up 2. And then we'll have that kind of same slope of 1/2 on the other side, but in the other direction. And then we could go ahead and connect that. And here would be our graph, except I didn't get it exactly. Here we go. Okay. And then it continues on forever. Also, if you wanted to check some answers, and we could even start with this, but we want to keep in mind these graph transformations. What we could do is plug in some coordinates and make sure we're ending up at the right spot. So like if we plugged in -1, that would be 1/2 times 0, so +2. So we should have the coordinate -1, +2. And then plugging in 0, we'd have 1/2 + 2, so that would be a 2.5. So let's see, at 0, yeah, just about. And at 1, we'd have a 1 + 2, so that would be a 3. So 1, 3. So it just gives us some coordinates that if we're plugging into our given function, it should match up with the transformations that we carried out. All right, 2 more here just to get our practice in. So what I'm seeing is that exponent of 3 there. So our parent function is going to be cubic. Which again, I always just like to sketch this to myself, mostly so that I get the practice of getting the correct direction. So with this, our parent function, we have 0, 0, 1, 1, and 2, 8. And same in the other direction. And that just gives us some starting coordinates to follow. And then from there, let's see, we're going to need to do a little bit of simplifying here. We're going to need to factor out a 2 inside these parentheses here. So if I factor out a 2, that would be 2 times x minus 2. So we can see the true shift and horizontal compression or stretch that we're dealing with here. So now I could see we're going to have a horizontal compression by 1/2. That's coming from this 2 out front here, or I'm in the parentheses, but it's the multiplying 2. Remember, we always use the reciprocal for the horizontal. So we just 2 over 1, the reciprocal is 1/2, so that's going to be a compression. And then the 2 that's inside the parentheses here, so x minus 2, that's going to be our shift. And because it's -2, that means we're going to go right 2. Okay, so horizontal compression by 1/2. So we're going to squeeze things in and take 1/2 of these horizontal distances. That's going to make it real squished in there. There's our skinnier graph there. And then we're going to go right 2 units. Right 2, right 2, right 2. And right 2, right 2. So our final graph will look something like this as best we can. Okay, one more practice here. We're going to see our absolute value again. But with this one, we're going to see what just happened in that last one where we need to simplify a little bit to see our true transformations. So we keep this negative on the outside, but inside it's like the absolute value is similar to parentheses, where it's kind of grouping the items together. We're going to factor out a 2 in there, and then we'd have an x plus 3. So that's where we can see a separation of our horizontal compression or stretch, and then the horizontal shift. So this is our absolute value again. So we're going to have something like this for our parent function with a nice slope of 1 and -1. And then, so we have this negative out front. So with the negative out front, that's going to be a reflection of our y coordinates. So it's going to be a reflection over x. And then we will have the 2 inside is going to be our horizontal compression by 1/2, because we want to use that reciprocal. And then the 3 that's inside, because it's a +3, will be moving left 3 units. So let's take care of that reflection over x. So all of our positive y values become negative. Then let's go ahead and do our horizontal compression by 1/2. So all those horizontal distances are going to shrink in there. And then let's go ahead and move left 3 units. So let's go 1, 2, 3. And then we're following a slope of 2. And there's where we end up after all of those transformations. Okay, so the next video we're going to look at some more functions, but hopefully this gives a good idea of how to identify absolute value, quadratic, and cubic, and also how to get started with graphing them.